we will now go through 3 hardware features which cannot be used for a sequentially consistent machine unless we use additional instructions to ensure synchronization and to avoid the problems that these hardware features introduce. And these special instructions, they obviously take more time to execute than normal reads and writes, loads and stores. Okay, so what are the features that complicate things? And recall, this is in a system without any cache memories. So first is write buffer with read bypass. And we will see how Decker's algorithm will break down with this. And then it's overlapping writes. And we will look at the program with A, B, and C and see that it also may break down. And then we will look at another example for non-blocking reads. So first we need to be aware of how store instructions are performed by a CPU. It is much more important to get data from memory than from putting data into memory. Normally, you can think of a single-threaded program. When the CPU has decided to put some data in memory, it doesn't really have to wait for that data to reach memory. It can go on with other things. But when it reads, it usually cannot do much else other than waiting for the data to arrive from memory. And therefore, there is a queue, I mean not therefore, but there is a queue of these writes, but I should say therefore, reads can skip this queue. So they will go ahead and be executed before the stores that the CPU has already executed. Okay? And for this case that we have no cache memories, then this FIFO queue is between the CPU and the bus interface. So what does this machine look like? Well, there is a bus that's a common communication medium that all connected devices such as CPUs and memory can hear everything else that anyone says. Okay, so when there is a read bypass, this read will go to the bus before the earlier writes and access memory. And what will that lead to in Decker's algorithm? Well, the first thing that happens is that both CPUs set their flag to true. Okay, and if this FIFO queue was empty, then these writes would go directly to memory and everything would be fine. But suppose there are other stores already queued in this. So these writes to flag will not occur immediately, and instead the read bypass will be done so that the reads of the other thread's flag is done before writing the own flag. Then what can happen then? Well, so what we basically do is to swap these lines, well, maintaining the while syntax instead. Of course, still I should say. So, but what will happen is that we read the other thread's flag and then write our own. So that means both can read false for the other and both can enter the critical section. So it doesn't work. No. Okay. And for overlapping writes, that means that there can be multiple writes in the system at the same time. And I already mentioned what could happen for this program here. So if the writes can be overlapping, then this write starts, and this write can start as well, since they are allowed to be overlapping and not done one at a time. And then if the machine is quite big, so that each CPU sits in like its own chess square, then the value of B may reach T3 before the value of A. And since they are overlapping, we cannot guarantee any order of when they arrive. This is actually exactly the same problem as for actors. We don't know the order of the messages from different nodes, which one arrives first. Only messages from the same node. And as we will see, the hardware, how it implements sequential consistency is by using something very similar to actor model. Okay, so that doesn't work either. And non-blocking reads, what's that? A non-blocking read is done to speculatively execute code, and that means an access, memory access, can be done before it's actually needed. So the CPU guesses that it probably will need this value and fetches it before. Okay, so let's see what happens. Here we have two ints, and this thread computes something, and then it writes 1 to this F. And this waits until F becomes true. Okay, so then it leaves the loop and prints the value of A. But the problem here is that by speculative execution, the value of A, I mean the variable of A, this reading, can have been performed before entering the while loop by the CPU. It can reorder the instructions, and it can fetch it speculatively. It's very reasonable to do so, because eventually it will go here, possibly, or loop forever. Okay, so non-blocking reads are not allowed either. And non-blocking reads, they are important in so-called superscalar CPUs. And a superscalar CPU is a CPU which can firstly, it can start executing several instructions at the same clock cycle. And for that to be useful, it can guess which instructions should be executed. I mean, which branches will be taken, and then it guesses which instructions probably will be executed in the future. And then, of course, it has mechanisms to handle any mis-speculation. If you are interested in learning more about that, take a course on computer architecture or the efficient C course, which we also studied that.